Welcome back. In this video, we're just simply going to be reviewing what you need to do to prepare for the first major exam in class or in person. I'd like to also review section 4.9. You ought to read this, but some of the key things, they talk about what is the same and different about real life and what we've been doing in this course. And the first thing that they want to point out that I think is really important is that real chemicals have impurities. We've been working all of these problems as if everything is pure. The reality is there's always going to be impurities. Sometimes these impurities are large enough that you need to take those quantities into account. Sometimes they're trace amounts and we can just ignore them. Second, in real life, steady state isn't really a thing, okay? And measurements are never really this accurate. So there's always going to be some, inherent error to our calculations. These are going to be approximations to reality because of the variability with time. Another issue is that real life problems will frequently have too much information or too little information. So when we do those degree of freedom analysis, it becomes even more critical when you're working on a problem in real life. If you find that you have, something, instead of your degrees of freedom being, 1 or 2, you find out that you're ending up with 5, something like that, then perhaps you need to go digging for some more information. A big problem, though, is when you get those negative degrees of freedom. Many times our negative, if we're talking maybe a -1, it usually means that we've listed an equation that is actually dependent, okay? Maybe we have things that were always in the same proportion or something where mathematically they were dependent. And so therefore really we had a well-posed problem. But in real life, you can frequently be given too much information and it will be contradictory. Those are probably some of the toughest things you have to face on the job. You're going to have to learn to make judgments of which of the given information is credible and which needs to be just treated as advice, not an actual physical measurement. Another issue, multiple answers can sometimes be possible from the math, and you'll have to choose what's best. We ran into this already with the equilibrium problem. Frequently, we can eliminate other answers from the math by simply looking and saying, oh, well, this one isn't even physical. But other times, we'll just simply have to have a deeper understanding of the physical reality, and that'll come better as we have more practice and experience. Another issue, your approximations and assumptions that you make may not be appropriate. That's why we write them down. It's always good practice to write these assumptions down or any place where you make an approximation, because later if you find out that it was a crummy approximation or a crummy assumption, you can go back and fix that and you know where in the problem solution that needs to change. Dealing with reactions, sometimes you think you know the reaction network and it turns out that something else is occurring. Again, this relates back to those impurities in the chemicals. Sometimes the impurities may include things that cause side reactions that you didn't even think about. And finally, errors are everywhere. There's going to be human error. There's going to be instrument error. Someone will swear to you that the pressure is, this. And really, what they forgot was that, oh yes, this pressure transducer has an inherent error in it, and you always have to add 3, okay, because it's just got an error. So there's going to be instrument errors, and a lot of times we don't know about them. So that's going to be tricky. And then just random errors. Life is not perfect, so random errors will also cause us fits when we get to real life. So let's talk about how to prepare for exam 1. So first, I realize that this format is going to be new to pretty much everyone. So be sure that you have told me, the instructor, where you will be taking this exam, okay? Also be sure that you have verified with the testing center that you are using that they have you on their schedule and that you'll be able to take the test at the appropriate time. Now, this test is scheduled to be taken on Thursday or Friday of the 4th week of class. So you can set it up for any time during that period, but you have to make sure it works for the testing center. You need to allow 2 hours for the exam. I'm writing it so that it could be done in an hour if you really know what you're doing, but I'm going to give you 2 hours. I think that just with the novelty of the testing centers and so forth, that will just make it a little bit more comfortable for everybody. This is not going to be an open book, open notes test, but I will allow you one sheet of notes, 8.5 by 11 inch, front and back, or anything smaller, of course, would work also. But so come up with what you want on that sheet, okay, and bring that with you for the test. You can use a calculator and your own pencil, pen, eraser, whatever. You may not use a computer on this test. So I know your textbook is on the computer, all your old homework is on the computer. You're not going to be allowed to have those with you for the test. Now, what's going to happen is you'll go into the testing center, you'll show them your ID to prove who you are, and they will give you the test. At the end of 2 hours, you'll turn it back into them. At that time, they will need to return the test to me, and I will be sending them an email telling them that I want a PDF scan of the exam, and then also for them to mail the original back to me. The format of the exam is going to be 5 questions. Each question may have multiple parts to it. They're all going to be open-ended, so unlike the little online quizzes that have been largely multiple choice, some fill in the blank kind of things, these are going to be all open-ended. If they have multiple parts, sometimes one of the parts will require an answer from a previous part. I will give you a numerical answer if it's required to use. So like maybe the actual answer for part A was 3, but in part B you needed that answer. Well, maybe you weren't able to do part A or you weren't sure you were right. So I will tell you that using the answer from, or using the value of the answer in part A was 5, not what the real answer was, solve for, and then I'll have you work part of the problem. So there won't be like a growing problem just because you couldn't do the first part of the problem. So if you get stuck on an early part of a problem, go ahead and move on to later parts and see if you can do those. And maybe later you'll be able to come back and do the first part. The material on this exam is going to be from units A, B, and C, so the first half of the course. I will be posting some old exams from a course that was taught in a very different format. So I'll post those in our Canvas website for you to at least have a little bit of practice and experience. So what do you need to be able to do to perform well on this exam? You're going to need to solve problems with a variety of units. So you need to be able to do things with densities, specific gravities, mass, volume, flow rates, moles. You're going to need to work with chemical compositions that can be defined in either mole or mass fractions and convert back and forth when you need to. We saw that in some of the later examples that I was trying to add those skills back in. Part per million and part per billion shouldn't be that tricky, but it sometimes is confusing. So be sure you know how to use those, because probably somewhere on the exam one of those terms will show up. You should be able to select reasonable equations for data using curve fit information from Excel. Now remember, you don't have the computer on the exam, so I would have to give you results from Excel in order to do that. And then you should be able to analyze steady state or batch processes without reactions using the proper problem-solving techniques outlined in the book. So you're going to define a basis, draw a drawing, put a material table together, do a degree of freedom table, etc. You also want to be sure that you can demonstrate your ability to use the terminology associated with reactions. So in particular, yield, selectivity, conversion, extent of reaction, being able to define what's the limiting and excess reactant, Those are going to all be key to being able to do problems with reactions. So you should be able to solve material balance problems that have multiple units, that have recycle, that have bypass, that have purge streams. You should be able to distinguish between overall and single pass conversion and yields. You should be able to balance combustion reactions and solve material balance problems that involve combustion reactions, as well as multiple reactions, single reactions. I hope that this helps you prepare for the exam. Again, take a look at some of the old tests that I've posted for you and make sure that you are fairly facile at working these problems. This is a skill that really requires a lot of time and practice. You're not going to, look at the problems and say immediately, oh, I know exactly what to do. Until you've put in enough time and practice, this is very challenging. At some point, you'll be a senior and you'll look back at this and say, oh my goodness, that was ridiculously easy. Okay, don't be discouraged but if someone tells you that is at an upper level. It is easy once you've had that experience and practice. So work on the practicing, and we'll see you at the test.